different properties, different depths, different hardnesses, and hugely different ecological impacts.
What I'm going to do is make a thin wall so that when you look through it from this side, you can see the sun shining through and see all the stratigraphy. So we'll see how it works.
One of the big takeaway messages was something we kind of knew, but we hadn't seen it on that grand a scale. The Arctic really can be divided into four things: the big glaciers, Greenland, and the glaciers of the Canadian Arctic, the sea ice, and we'll take those away for a second, and that leaves the land, and the land is either taiga forest or tundra. They both get about the same amount of snow, but one, the taiga forest, tends to be quite windless, so that snow falls, and once it's on the ground, it stays there. The snow of the taiga is particularly characteristic. You can kind of see here, nice, fluffy. The one thing you find out in the taiga is you can get stuck real easy. Look at this. There's almost no strength. It's really soft, real fluffy stuff. This snow could have fallen a week ago or a month ago and it'd still be just as fluffy. So taiga snow, the wind can't get down in here, so you get this kind of beautiful snow cover. In the tundra, we get a lot of wind. That sounds like a very minor difference, but it results in absolutely diametrically different snow covers.
If I we scrape this off a little bit and make it a little thinner. So the sunlight can shine through it on this side. We see a couple very, very obvious layers. There's from the top down to here, and then from here down to the bottom. On the trip from Fairbanks to Hudson Bay, basically the first half of the trip was in the forest and the second half on the tundra. And so that difference was beautifully manifest. You couldn't escape it anymore, because really all that was different was how much wind and were there trees or no trees. This first the big layer here goes down to about 22 centimeters, and then down to the river ice below. One thing we can see, the snow grains in these upper layers are actually much smaller than these real coarse, heavy grains that you see here.
Can you tell us why those big coarse grains are there?
The coarse grains are called depth hoar. They're caused from the relatively warm lake or river ice surface in this case, and then relatively cold air temperatures. There's a temperature gradient from warm to cold, and associated with the temperature gradient is a vapor pressure gradient. So we have high temperature and high vapor pressure and low temperature and low vapor pressure up here. So there's a migration of the water vapor molecules from deep in the snowpack towards the surface, and that recrystallizes these guys throughout the winter. So in general, the larger crystals are associated with older snow, which is, of course, deeper in the snowpack. So you can see these are much smaller, these surface crystals. They're maybe 100 times smaller than these big guys. It's a couple weeks or a week old even.
Okay.
So on the one, we had this beautiful crystalline substance that promotes a very good subnivean environment. The other, dense, hard wind pack in places could barely make a dent in it with a steel shovel. So that really struck me at this very broad scale of a way to think about the terrestrial parts of the Arctic and separate it into those two parts. They have enormous impact on both permafrost, on the animals, whether they're going to be caribou, who lives where, if you will. And it had been seeping in over the last 2 decades, this difference, but it wasn't ever that clear and dramatically laid out for us. I really like seeing that transition.